Hi, welcome to our second live Maths A-level session. I hope you're all well. You had a great start to the week. Hi, Yasmin. Great to see you all joining for this second session. We are going to be looking at differentiation from first principle. We'll start in a couple of minutes. Let's see if anyone else is coming. Will this be throughout the year? Yes, this is the second lesson that I'm doing. This is going to continue weekly. So these are the A-level sessions. We also have GCSEs, and if you're doing other subjects, there's physics on Sundays as well. So this is going to continue weekly. Hi, Kosara Lee. Welcome. Nice to see you. So the way these sessions work is I will, for the topic that we picked, I'm going to give you an introduction to it. I'll teach you how the topic works, and then we'll look at some exam questions and we'll solve them together. So if you have any questions as I'm explaining the topic, please let me know in the chat. Right, Yasmin, you're asking what differentiation from first principle is. So we'll see that in a sec. Basically, this is one of the topics that's in all exam boards for Maths A level, and differentiation is something that you see and you know how to use, but we'll see what it actually does and where it comes from. So we'll have a look at what it means in a second. So let's see what we will talk about today. So if you have seen done differentiation before, you would know that we can use it to find gradients of function. So we'll talk about the relation between gradients and differentiating. So why we can find the gradient by differentiation. Then we'll see where this formula comes from. So this is if you're doing A-level maths, this will be given to you in your formula booklet, and it says that the derivative of a function f of x is the limit of f of x plus h minus f of x over h. We'll see where this comes from, and we'll see how to use this in answering questions. So I will assume that you know how to find the gradient of a straight line, and you have seen functions and binomial expansion before, because we use those two topics in actually applying this formula to questions. Okay, so let's start with finding the gradient of a line. So suppose we have a straight line. I have got 2 points on the line that I know, x1, y1. I've labeled them with just general x coordinates and y coordinates. So can anyone tell me how we can find the gradient of this straight line? I will call it m. So if we label the gradient m, you should remember from doing straight lines that the gradient is given by, if you consider this triangle, it's going to be the difference in the y coordinates, y2 minus y1, divided by x2 minus x1. Well done, Ryan and Yasmin. Difference in so we have the difference in the y coordinates divided by the x coordinates, x2 minus x1. So this is for a straight line. But what we are really interested in is being able to find the gradient for a curve as well. So if we have a curve like this, let me draw one. That wasn't very smooth. That's maybe a bit better. Suppose you want to find the gradient on this curve, and you have got this point. Again, I'm going to call that label that point. So I will label that x, and if we call this y equals f of x, it could be y equals x squared, it could be y equals x cubed minus 3, whatever your function is. Well, I can, this is a point xy, or we know that y is equal to f of x, so I can call it x and f of x. So we want to find the gradient at any point here, and Ryan, you are suggesting use a tangent. Well done. That's what we are going to do. So using a tangent is one way of finding the gradient. Let's draw a tangent. So what we can do is say attempt to draw a tangent like this. But the issue with drawing a tangent, doing it graphically, it's one way, but it's not going to be perfectly accurate. We may have this may be a tangent, maybe you can draw another tangent, it looks like that. So although it's a valid method, that's graphically valid, we want to be able to do this algebraically. We want to be exact. So to do that, what we'll basically draw a tangent and make it a better and better estimate. So suppose I start with this particular line. So I know this is a very bad tangent, but that's on purpose. The idea is we are going to make that better and better. So suppose this tangent touches the curve at another point, and this distance is h. And the h you can recognize. We are going to come back to the h. It appears in your formula. And that we'll see why we are looking at why that h is used. So what's going to be the x coordinate of this point then? If it's x, if it's a distance h away from our initial point, we can call it x plus h. And the y coordinate, we can call it f of x plus h. So it's just another point on the curve. We have drawn a tangent, but it's not the perfect tangent. It's a bit further away from the curve. And thank you, Ryan. Because it's not a perfect tangent, it will cut the curve at a different point. Mo, you asked, is this Cambridge or Edexcel? It's in the Edexcel syllabus, and it's for the other exam boards as well. It's you have differentiation in Cambridge too. So this is something that applies to all the exam boards really. Right. Can you tell me how we can find the gradient of this curve then, this straight line then? This is a tangent. We are going to we want to find the gradient of this one. Just like the previous one here, we can use the same formula. We can use this, and we can say we are going to take the difference in the y coordinates. which is going to be f of x plus h minus f of x. That's the difference in the y coordinates. And we divide it by the difference in the x coordinates. So that's x plus h minus x. So if you simplify this, this will be f of x plus h minus f of x divided by h. So you can see this is already looking similar to the initial formula we had. But this is, we don't have the limit yet. We'll see what the limit means in a sec. Salma, why is the y coordinate f of x plus h? So the idea there is that we have got this curve represented by f of x. So that's your function. F of x can be anything such as x squared, or it could be x squared plus 3, or it could be x cubed. It's your function. That's your f of x, and that's why the y coordinates are for the way the function works is that when you have the x coordinate for any x, the y coordinate is f of x. But if instead of inputting x into the function, which is there, you're inputting x plus h, that's your x coordinate, then the y coordinate will be f of x plus h. So that's basically what comes out of your function. So here now we have got the gradient of that tangent, but we said that the tangent wasn't really the perfect tangent. You can see that it's quite far. So how can we make this tangent better? Do we really want to have such a large h? If I draw this one, is it going to be a better tangent compared to the purple line? So this one will have a smaller h. So the idea here is I want to make h as small as possible, because you can see here the purple line has quite a large h. It's not the best tangent possible. You can draw it one closer and closer. So minimizing h gives you the best tangent. Let's make a note of that. So we want to minimize h. Yes, that's correct. Thank you. You want to make h as small as possible. What can the smallest h value we have be? You can see that in this in the way I drew them. H got smaller with the red line. We can make it a bit smaller. But what do you think is the limit that h can go down to? So the minimum value we can have is 0. We are making it as small as possible, and this is where the idea of taking the limit as h goes to 0 comes in. So minimum value is 0. That means we look at the limit as h goes to 0. So this is why if we are talking about just the tangent, just this straight line, the purple one or the red one, we write that the gradient m is given by this. It's the difference in y over difference in x. Thank you, Salma. Hugo, you're all correct. But if you want to find the gradient of the curve, which is the best possible tangent, we take the limit when h goes to 0. So that's why we have got this formula. Instead of saying a gradient of a straight line m, when we are interested in the gradient of the curve, which can be represented by f dash of x or dy by dx, it is going to be given by the limit as h goes to 0 of f of x plus h minus f of x divided by h. So this is the formula. You are given this in your formula sheet. You need to know how to use this, and we have just seen where it comes from. It is essentially saying that the gradient is taking the difference in the y coordinates divided by the difference in the x coordinates, but it's a limit, meaning when we put a function in, when we have an actual y equals x squared to differentiate, you will need to take the h value as small as possible. Right. Now we are going to move on to answering some questions, seeing how this formula can actually be used. How are you finding this? Let me know if you have any questions. Is this easy, difficult? Let me know in the chat. Am I going to cover more here to content? Yes, there will be. I mean, in this today's session, what we have done up to now is year one. You need to know this for year one. In the questions I picked, some are year one. The last two questions are year two. So I'll point out when it's the year two of this. But this topic you need to know for you would have done it in year one as well. And in the next sessions as well, you can find the timetable of what next sessions are on the Physics and Maths Tutor website. We have both year one and year two topics. Implicit differentiation scares you. I can understand you. That can be a tricky topic. I mean, it's definitely something we can look in the coming sessions. Right, let's move on to the questions and see how we can actually apply that formula to questions. So here the question says prove from first principles derivative of 4x is 4. If the question was differentiate 4x, you would just be able to write down 4. So I'm sure if you have done differentiation, this is one of the first types that you would have done. You know that 4x differentiates to 4. But we need to prove this from first principles. And when the question talks about first principles, you need to remember that formula, which is f dash of x is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. I'm writing it here again so that we can we have it in front of us and we can substitute into the equation as we calculate the rest of the expression. So let's see what we have here. We have got f of x plus h and f of x in our formula. So the first thing we should realize is that the function f of x is 4x in this question. That's given to us there. That's our function. So we want to differentiate that from first principles. Then you should really be comparing what you have in the formula. We have got f of x we said that f of x is 4x, so that can be substituted, but we need to find f of x plus h. So if you write f of x plus h, that is going to be 4 times x plus h. So this is a quick recap about functions. Our function originally it was 4 times x. That's when you put your input is an x, but instead of x, our input here is x plus h. That's why the f of x plus h becomes 4 times x plus h. So when you combine this, when you put this back into the formula, we have got f dash of x is the limit. So we have got 4x plus h. So that's this substituted. Then we have got minus f of x. So I'm taking away 4x, dividing by h. Let's continue. I'm not doing anything with the limit yet. Just I want to simplify this section of the expression. So we have got 4x plus 4h minus 4x divided by h. And then you can cancel out the 4x's. So you end up with 4. You can see that here the h cancelled, so we don't really need to worry about h going to 0 with the limit. The h term doesn't appear in the expression. So limit as h goes to 0 of 4 is still 4. So we have shown that when you differentiate 4x, you get 4. So this is the another way of thinking of this is the gradient of the best possible tangent is going to be 4 here. Okay. Let me know if you have any questions in the chat. This was a more straightforward one. In the next question, we have got a bigger expression for f of x. So we are given f of x is x squared minus 4x. We want to do the same approach. And remember, I'll remember the formula. I'll write it down here, or I'll copy it from there. Okay, that's the formula we have. We are given our function. So let's consider what this part is. So for every question, my approach is simplifying the expression, the yellow highlighted expression, finding what f of x plus h minus f of x over h is. And then at the end, we can see what happens when h goes to 0. So let's do this. We have got f of x plus h minus f of x divided by h is, to find f of x plus h, you substitute x plus h into wherever you see an x in our function. So we have x plus h squared minus 4x plus h. Then you take away your function, which is x squared minus 4x. We divide this by h. So you should expand this, and when you expand the terms, you will be able to simplify the terms. And let's see what you get. Let me know what your expression simplifies to. So I'm going to expand this bracket. So we have x squared plus 2xh plus h squared. Then take away 4x minus 4h minus x squared plus 4xh. We divide everything by h. Let's see what we are left with. This will cancel that term. Then we have the 4x's should cancel. This doesn't have an h there. So the 4x cancels this term. So we have got 2xh plus h squared minus 4h over h. And then we simplify this. You divide each term by h. We end up with 2x plus h minus 4. So this is as simple as you can get, but this was not with the limit brought in. So this is, if we go back to the beginning, this expression is the gradient of this purple tangent. It's not the best gradient. It's just the gradient of a tangent that you drew, but it was not the best gradient. To make it the best one, you need to make h as small as possible. So making h as small as possible means taking the limit as h goes to 0 of whatever that expression is. So this plus h minus 4 is going to be, well, what happens when h becomes 0? So the limit, you can think of it as it's literally becoming 0. So when h is 0, you can say that this goes to 0, which means this expression is just 2x minus 4. And that's what we wanted to, what the question wanted us to show. We have we had f dash of x is 2x minus 4. So we can write, therefore, f dash of x is equal to 2x minus 4. Yep, that's right. You are taking h, you took h as 0. Yes, the video will be up on the YouTube channel. So this is being recorded. I will also upload the notes and the questions we are solving as well. So the link will be in the description. Okay, so this was another question with with x squared in it. Let me know if you have anything you want me to clarify in this one. Then we have got a cubic function. Let's do this one as well quickly. You can see that the approach is always the same. So remember, up to now, these questions, the questions I've done up to now are all in year 1 content. So if you are doing AS level, if you're in year 12, you should have done these. And if you make sure you're able to do these. Then the next ones will be for year 13 or second year only. So we have got our function. Again, I'm highlighting that. That's x cubed. We want to start with simplifying this expression. So let's start by expanding, by writing f of x plus h minus f of x over h is. Let's find what this is. Let me know what your expression simplifies to. So you will put x plus h into wherever there is an x, so that's becomes x plus h cubed. You take away an x cubed and we divide by h. So this is going to be this is where you need binomial expansion. So we have got x cubed plus 3x squared h plus 3x h squared and h cubed minus x cubed. We divide this by h, have a look at what cancels, the x cubes go away. Then we have, let's see what we can simplify. So we have got 3x squared h plus 3x h squared plus h cubed, all divided by h, which simplifies to 3x squared plus 3xh plus h squared. So this is the simplest expression. This is the equivalent of the gradient of the tangent with which is not the perfect tangent. We want to make this as good as possible. We are gonna take the limit as h goes to 0. So the limit is making h as small as possible, making h 0. Well, if you look at the expressions, h squared, when h is very small or when h is 0, this is going to be 0. Similarly, this term is 0 because you have got 3x, whatever 3x is, doesn't matter. When you multiply any value with 0, it's going to give you 0. So the limit of this is going to be 3x squared. So that again shows is the same as what we wanted to get to at the beginning of the question. So that's saying the best, the gradient or the best tangent that we can draw, which will have 0h value, is going to be 3x squared. Okay. This is the next question, which involves differentiating trigonometric functions. So this is the second year material, or year 13 material. If you're in year 12, you would not have done this yet. So the approach is the same. We still want to find the best possible the gradient of the best possible tangent, but instead of a quadratic or a cubic, our f of x is cos theta. The question gives us some assumptions that we can make when it says that when h becomes really small, we can assume sine h over h goes to 1 and this term goes to 0. We'll see how they help when we expand our expression and find what it simplifies to. So as before, let me paste what the formula is. And we want to find f of in this case we don't have x, so I will just replace it with theta, and theta. Yep. So I want to find what for f of theta equals cos theta. I want to find what f of theta plus h minus f of theta is. Okay, we can see there is an addition formula here. So if I substitute theta plus h into cos, we have got cos of theta plus h. Can someone tell me how I can expand this? What's cos theta plus h? Says you can assume the formula for that cos of a plus b. So I should have cos of theta plus h minus cos theta all over h. So using the addition formula, this can be written as cos theta cos h minus sine theta sine h minus cos theta all divided by h. Now, what I did here is use the addition formula here for this expression. So the addition formula for cos A plus minus B is, let's use this, cos A cos B minus plus sine A sine B. So that's something you would have seen in trigonometry. But assuming that the question doesn't want us to prove anything regarding to that, we can just use that formula. So assuming that we have this expression. So let's continue simplifying that. We have got cos theta. So if you look at this one and that one, you can factorize a cos theta out. So that will give you cos h minus 1 minus sine theta sine h all divided by h. So now I can split these into two expressions so that they look something like these actually. We have got cos theta cos h minus 1 divided by h minus sine theta times sine h over h. So now you can see we have got both of the highlighted expressions. Let me move that there. We can, the question tells us that we can assume this one, so cos h minus 1 over h, that's that one, goes to 0 as h goes to 0, and we will also be able to assume this, which is here. But at this stage, we have not taken the limit yet, so this is the gradient of the tangent. That's not the best tangent. So to make it the best possible tangent, we are gonna say the limit as h goes to 0 of that whole expression, which is cos theta minus sine theta h is. So remember what we are given was this is going to approach 1 and this is going to approach 0. So when h is very small, that's what you get out from sine h over h, and you get 0 from the cos expression. What you need to do is simply substitute them in. So we get, let's see, so there we have got cos theta times 0 minus sine theta times 1, because this went to 0 and this went to 1. Well, that means we are going to get minus sine theta, because 0 times cos theta is 0, then and minus sine theta times 1 is minus sine theta. So that's differentiating cos theta from first principles. As you expected, we have reached minus sine theta. So you can write d theta of cos theta is minus sine theta. Okay. Right, that was a trig function that was differentiating sine theta. The last question I want to do is differentiating cos theta or cos x. It's very similar. So we'll still need to use the double angle, not the double angle, the addition formula, but sorry, I wanted to do sine theta, differentiating sine theta. So this is the wrong one. Let's not do this. Let's do differentiating, find d theta of sine theta. Do you need to know how sine theta over theta becomes 1? Well, no, the question tells, in that particular question, you could just assume that. So you don't really need to know how. And in general, you don't really need to. It's if you do, you can prove that using Taylor expansions. You can see why that happens. But to give you an idea, so you're asking sine theta over theta. So the idea there is, if you consider the sine curve, this is what sine roughly looks like. So we are looking at what happens when theta is very small. So this is, say, this is h, sine of h over h, but as it becomes very small, we are looking at 0. So you're essentially zooming into this area, and that becomes like a straight line there. So that's why it's you can approximate sine h with a h, or sine theta with a theta, because this becomes very much like a straight line with y equals theta. So that's why you can approximate, say, sine theta divided by theta as theta divided by theta, which is equal to 1. So that's where it comes from, but for if you don't really need to know, you can just quote that result. The question is giving that to you. Okay, let's do the last question. It's this one. So that's from first principles. So let's write f of theta plus h minus f of theta divided by h. So can you tell me what the addition formula for theta plus h is? Who can tell me? Does anyone know that one? So we have minus sine theta divided by h. Okay, you said you're asking about 0. Let me have a look at that. So the question, let me go back to that. Well, what you were given before was what happens when sine theta over theta, what happens when theta becomes very small. It's well, yes, when it approaches the 0, that's how you find what happens, and it's exactly because you can't divide by 0. You're right, that causes the issue, so you can't simply get an answer. That's why you need to say, okay, when it's not actually totally 0, but it's very close, it's like it's approximated by a straight line. So that's how we approach these questions. Yeah, so we have the formula for the addition formula: sine theta cos h, cos theta sine h. Yes, that's correct. Ryan, I think you have it. Sine theta sine a. So that's no, that's more like the cos addition formula. So check that you have the correct one. So we have got sine theta cos h plus cos theta sine h minus sine theta. Okay, and then we'll need to do something with this. What factorization or any simplifications can we do? What would be your next step? Let me know, please. And remember, if you, I would assume if you did trig differentiation, you would know we are aiming to get from sine theta, the answer at the end will be cos theta. So we can factor out a sine theta. Then we have got cos theta sine h over h. So the approximations are going to be the same. We can take this to be 1, and this is going to be 0. So the first term is completely 0. We end up with cos theta. So you write that the limit as h goes to 0 of sine theta cos h minus 1 over h is cos theta. So that's how you do, how you find the derivative of sine theta from first principles. And these are the two trig functions you need to be able to differentiate from first principles for your courses in A level. That's where I will stop for today. Thank you very much for joining this session. I will be putting the recording on the YouTube channel, so you can watch it later, and the notes and the answers that I have been making will be in the description. So if you like this session, please subscribe. I'm having these sessions regularly every week. We are gonna have Maths A level. We have got Physics A level on Sundays, and if any of your friends are doing GCSEs, there are GCSE sessions on Wednesdays, starting with maths. Thank you very much for joining, and hopefully I'll see you next week.